In the last lectures, we have seen the partition of quicksort algorithm with the help of examples. Today, we are going to learn the quicksort algorithm. So, what is this? Quicksort array, pivot element, first element or last element, we can say, because every time we are choosing pivot element as the first element. So, if p equal to q, it means there is only one element. Then what it will return? It will return pivot element. Else what it will do? It will do the R partition array p q quicksort a p r minus 1, because what we will do in the quicksort partition, so till r minus 1, then quicksort a r plus 1 q, because r will give us the partition. So up to this one time, because we know in the partition the element before the pivot element are less than pivot element, and after that more than pivot element, but they are not sorted. So for the doing sorting after the partition, what we are doing, quicksort a array pivot element r minus 1 up to, it will go, and quicksort a array r plus 1 comma q, the last element, then it will return a. Like that it will work. So if only one element, so order of one time. And because we have seen, if we are doing partition, because so we are cross checking all the elements. If we are supposing there are n elements, so order of n time, and this is t r minus p, and this will take t q minus r up to L, so r minus p, and up to q, so q minus r. So like that it will work. So now we'll see what will be the recurrence relation for the quicksort. Recurrence relation will be 1 if n equal to 1, and it will be order of n plus t r minus p plus t q minus r if n greater than 1. If n greater than 1. What is this? This is pivot element r, and this is first element, this is last element, because we know r, it means we get the pivot element, and p equal to q, it means if only one element is there, so both will be equal. So partition, with the help of partition you get pivot element. So first will go before the pivot element r minus 1, after that it will go r plus 1 q, because pivot element is at the correct position. So this will be the recurrence relation of the quicksort. So in the case of best case, or we can say the average case, best case or average case, what will be the recurrence relation? Recurrence relation will be order of 1 if n equal to 1, otherwise n plus t n by 2 plus t n by 2 minus 1 if n greater than 1. If n greater than 1. So if you are going to solve it, then tn is equal to 2t n by 2 plus n, so again 2 square t n upon 2 square plus 2n. Like that if we'll go up to k time, then what we will get? We will get 2kt n upon 2 to the power k plus kn. So if we suppose n upon 2k is equal to 1, so n equal to 2 to the power k, then log n base 2 is equal to k. So from this what we will get here, 2 power k is means n, so here n will come, and n upon 2 to the power k, again n, so n upon n, it will be t1, and k instead of k log n, so it will be n log n, these two. So the complexity will be n log n, best case or average case. But if we are talking about the worst case, then what will be the time complexity? The recurrence relation will be like this: order of 1 if n equal to 1, and n plus t0 plus tn minus 1 if n greater than 1. What does it mean here? Because best case or average case we are saying, it means pivot element is in the mid, so one part will be tn by 2, and because of pivot element it will be tn by 2 minus 1. And here, because we are talking about the worst case, so we can simply say pivot element is like that, it is on the one side only, or all the elements on the rest of the side, so it will be t0 plus tn minus 1. So that's why it is called worst case. So if we are going to solve it, then what we will get, tn is equal to tn minus 1 plus n, again tn minus 2 plus n minus 1 plus n, like that. It will, if we go up to n times, so what we will get, we will get t n minus 1 plus t n minus 2, like that. If we go in the end, we will get n minus 1 plus n minus 0. So here we can say n will get cancelled, and n will get cancelled, like that. If we solve it, then what we will get, t1 plus t2, like that. We will get up to n, because at the end n minus 0, so it will remain n. So like that it will go, so it will be 1 plus 2 plus 3, like that, n. So if we are going to solve it, so it will be n plus 1 by 2, means simply order of n square. So we can simply say, in the best case or average case, complexity will be n log n, and in worst case, the time complexity will be order of n square of the quicksort. So this is all about the quicksort.